Hi, my name is Ian Wolfe, and I'm an undergraduate student here at California University of Pennsylvania. And this presentation is on the conformational studies of a novel Paraburkholderia isolate that was taken from an acid mine drainage remediation site. Now, to start off, I'd like to give you a little introduction on what acid mine drainage is. So, acid mine drainage comes from runoff from old abandoned coal mines and metal mines. Currently in the United States, there are over 500,000 miles of abandoned mines that are scattered all across the country. It is especially bad here in southwestern Pennsylvania because this area was a coal mining area. And the main problem with acid mine drainage is that there is no way to completely stop it, it's irreversible. You can only treat it. There's even cases of Roman mines that are over 2,000 years old that are still producing acid to this day. And it is one of the leading pollutants to watersheds all across our country. It directly affects wildlife, our agriculture, habitats, and our drinking water. Now, there's actually two kinds of mine drainage. There is circum-neutral mine drainage, which is characterized by having a neutral pH and has high iron levels. And then there is acidic mine drainage, which has a low pH and high metal contamination. Now you might be asking yourself, what is the cause of the acid in the acid mine drainage? And that comes from pyrite oxidation. Water and oxygen cause pyrite to oxidize, which results in sulfuric acid, creating an acidic environment. As mentioned earlier, mine drainage can be treated, and this is done through passive treatment or active treatment. Now, passive treatment, once it is built, it costs almost nothing and it requires very little maintenance. There are no chemicals involved, it is all a geochemical and biological process. It works by having the water flow through various ponds, wetlands, and then eventually back into water streams once it has become treated. The downside of passive treatment is that it can become less effective over time and it requires a lot of land. Active treatment, on the other hand, requires a lot of maintenance, and it works by adding chemicals such as sodium carbonate, ammonia, sodium hydroxide, and manganese oxide to increase the pH and precipitate metals. It does cost a lot, however, it does work a lot faster than passive treatment. And the remediation site that my isolate was taken from was Boyce Park. It is a passive system that neutralizes 28 tons of acidity per year. And while no two remediation sites are alike, Boyce Park is characterized by having high levels of aluminum contamination, being around 70 parts per million, and has a high acidity with a pH of around 3. Now, to do this research, a sample was collected from Boyce Park and was plated on an R2A plate. Single colonies were then isolated and purified from here. The DNA from these pure colonies was extracted and sent out for shotgun sequencing. The genome was then sequenced and annotated through use of the Department of Energy Systems Biology Knowledge Base, or shortened to KBase. And from annotation, it was suggested that the isolate was novel. So to confirm this, an API 20NE kit was used, which is the standard for microbe identification. And the kit was done following the manufacturer's directions. Now, in order to fully confirm that it was novel, comparison strains would need to be used, and these strains were ordered. However, due to the current COVID-19 pandemic, they were delayed. So the results from the API kit were instead compared to literature. Also, during annotation, certain genes were searched for that confer to heavy metal resistance because of where the isolate was taken from. Where it was taken from has high levels of heavy metals. Growth curves were then done in the presence of these metals. And the metals that were used were aluminum, manganese, cobalt, copper, chromium, zinc, and copper. They were done by diluting the stock solution 9 times and then growing the isolate for 64 hours, reading every hour, or every 4 hours. As a comparison, E. coli was used. However, E. coli was only grown for 24 hours and read every hour due to the faster growth rate. The minimum inhibitory concentration was then determined of these metals. Minimum inhibitory concentration is defined as the lowest concentration of the metal that completely inhibits growth of the isolate. So from genomic annotation, a tree was created, which is shown on the left. And what this tree does is it shows all closely related species to the isolate. From this tree, an ANI test was done. An ANI test is the average nucleotide identity, and what it does is it compares the genome of the isolate to other closely related species from the tree. This test is a good indicator of if the bacteria is novel. And the threshold for this test is an ANI estimate of 95% or less. The ANI estimate for my isolate was 93%, inferring that the bacteria is novel. Now, from the API NE kit, the table is shown on the right. On the top of the table, I have the closely related species, the Paraburkholderia acidipaludis, Burkholderia ferrariae, Paraburkholderia oxyphila, and my isolate B1. On the side of the chart is the URE test, which tests for the enzyme urease, the ECS test, which tests for the enzyme beta-glucosidase, which is responsible for the hydrolysis of esculacin. The GEL test, which tests for the enzyme protease, and it is responsible for the hydrolysis of gelatin. The PNPG test, which tests for the enzyme beta-galactosidase, and then the MAN test, which tests for assimilation of mannitol. And now these are not all of the tests that are these are not all of the tests that the API kit tests for. These are just some of them. My isolate B1 was negative for the first test, as well as the Burkholderia ferrariae, and the other two isolates were positive for this. Isolate B1 was also positive for the ECS test, as well as Paraburkholderia acidipaludis. Now, the last three tests, the GEL test, the PNPG test, and the MAN test, my isolate was different from every other species that it was tested against. Now, because these results are only compared to literature and not done myself, I cannot yet say that the isolate is truly novel. However, these results yield that it is very likely that my isolate is novel. And from the growth curves, these are shown. On the left is the manganese growth curve, and on the right is the cobalt growth curve. On the y-axis, it is the absorbency at 600 nanometers, and on the x-axis, it is the reads. However, please note that read 1 would refer to a 4-hour growth period for the isolate, while only a 1-hour growth period for E. coli. The orange line on the graph is the control for the isolate, and the blue line is the last known concentration that growth was shown in the presence of the metal. And the gray line is E. coli at the same concentration of metals. Now, as shown for the manganese growth curve, the isolate was able to survive and thrive up to a concentration of 62.5 millimolars, while in the cobalt growth curve, it was able to survive up to 62.5 millimolars. However, it was not thriving. This is thought to be because it is more of a survival mechanism rather than a is able to thrive in it. The MIC for manganese for isolate B1 was 125 millimolars, while for E. coli, it was a lower MIC of 62.5 millimolars. And the MIC for cobalt was 125 millimolars, and for E. coli, there was no growth up to 1 millimolar. Now, the isolate also showed resistance towards aluminum and zinc. However, it did not show any resistance towards copper and chromium. So in conclusion, it is very likely that this species is a novel species of Paraburkholderia, although I cannot completely say that yet because I was not able to test it on the comparison strains. And it is also able to withstand high levels of some heavy metals. Now, this research is important because characterizing bacteria from acid mine drainage could help us further remediation efforts towards acid mine drainage. If I were to continue this research, which I plan on doing, I would compare isolate B1 to the closely related species that are ordered. I'm just waiting on them to get here, and then I would be able to fully confirm that it is novel. I would also like to find out if the bacteria being present in acid mine drainage is a positive or a negative. I'd like to give a special thank you to the Center for Undergraduate Research for sponsoring me with a grant to do this research, and also a special thank you to Dr. Michelle Avalkanis and the biology department for supporting me. Thank you for your time, and that concludes this presentation.